Hey, everybody. Hello, hello, hello. Happy Wednesday. Happy Eve of Christmas Eve for those who celebrate the holiday. And welcome. Well, as you probably know, for those who know me, I'm Dr. Cindy, your Johns Hopkins Yale trained OBGYN, PhD trained virologist, subspecialty trained reproductive endocrinology and infertility specialist, entrepreneur, medical influencer, and as you probably saw on the intro slide, I was recently named one of the top 20 Black physician influencers by Medscape, which is one of our online publications. So that was kind of cool. It was especially cool because I wasn't expecting it. It's really funny because, you're just looking at the Medscape article there, but I didn't expect it. And so one of my friends sent it to me via text and said, congratulations. So I was like, what is she saying congratulations for? I went ahead and tapped on the link, and lo and behold, I had been named as one of the I spend my days working to not appear like I'm serving special interests. And that's really because whenever I'm online with the intention of educating my patients, advocating for patients, advocating for people, for women, especially also advocating for women of color, but really advocating for women in general and girls around the world. And so it feels nice to be recognized for something that I'm not paid to do. I do this as a labor of love. I do this as some of me giving back. Today something remarkable happened, which is I spent my day today doing a number of shows. So I joined my friend Kalei Stewart for her Warrior Wednesdays program that she has on Instagram. And that was a hoot. You guys should go over and look it up when you have a chance at KStew222. So KSTEW 222. And we talked all about vaccines today, debunking myths about the COVID vaccine, etc. But we also, as we were talking, I was starting to realize something really important. So I was talking about the fact that the vaccines, the mRNA vaccine technology is not only has it been around for a long time, but a lot of it was actually developed via the National Institutes of Health here in the United States, which is our, trademark health conglomerate, so to speak, that's state-owned, which means it's taxpayer-funded. And I was saying, the thing to know about that technology is technically the taxpayers own it. It was taxpayers' investment into the National Institutes of Health that helped us get mRNA technology such that it could then be used in a vaccine for COVID and used so effectively that we now have two candidates authorized by the Food and Drug Administration from Moderna and from Pfizer BioNTech. And as I was saying that, I realized that I also am a product of public investment. So I am a product of an NIH-funded medical scientist training program. I spent 8 years at the University of Rochester in an NIH-funded program, earning my medical degree, my master's degree, and my PhD. And I didn't say it on the show, but it was a moment of reality in that part of my giving back to the community and the public is also in recognition of what the public did for me, which is public taxpayer dollars funded my education, funding a lot of my research, the training grants, and a lot of the Dr. Cindy you see today definitely is a result of some of those taxpayer dollars that were used to set up these medical scientist training programs. So me coming out to talk about vaccines, me coming out to talk about the technology and explaining to people virology and human viral interactions and how the immune system works and debunking myths. Some of it is me giving back. And you know what? That really, maybe that was my Christmas miracle, but coming to that recognition was huge for me. It was huge. And so we have some of our friends online on LinkedIn. Catherine Fasanella is saying, I want the vaccine like now. I also know Liana Ween. Oh, cool. Yes, yes, yes. Also on Kathy again. So she was actually saying, hi, Kathy, George Washington University Grad School, Milken Institute of Public Health. We have a grad student at Johns Hopkins, and my father was the chief of ophthalmology at Yale. Oh my goodness, Kathy, all sorts of connections here. Welcome, welcome, welcome. And so, you know, it's huge, right? So it's nice to finally see that some of the work, you know, when this pandemic started, for those of you who have been following me for a long time, you know that when this pandemic started and we had all locked down and I transitioned my clinic in terms of consultations to mostly telemedicine so I can keep serving my patients, one of the things I set out to do was to work on my social media footprint. And so I set out to work on, I'd already established Instagram for a long time. I decided to work on my Twitter, my LinkedIn, my YouTube, and Facebook more in terms of interactions and looking for ways to talk across all platforms at the same time, and hence things like what we're doing now. But I did that in part because I just wanted to personally challenge myself. I'm not someone who can just sit on my hands, but it's so cool to recognize that in so doing, other people also came across my work and thought, you know what, someone needs to hear her more. You know, this year we created so many things. I created the Physician of Black Women, the Directory of Black Women Physicians, which is on my website at drcindyduke.com. And that was created out of what I recognize as a need as well, which is that people keep saying they can't find Black female physicians. They don't know the ones who are online. If they're having topics they need to discuss in the media, etc., who do I reach out to? And I thought, well, why not create one place where you can find that, but also where patients can find doctors who are at the top of their game. And so that's how the Directory of Black Women Physicians came about, and that's been growing leaps and bounds. We're at 100 plus people in the directory, which we started with about 26 directory entrants. So we've more than quadrupled the directory, and it's still growing. And if you're a Black woman physician listening in here and you would like to be featured in the directory, you can go to the website at drcindyduke.com, find the directory under the Girl Powered Success and Survival tab, and you can enter your information, and then we get it. We do a quick vetting process, and then we'll post it on the directory. But it's been amazing in terms of what this year has been in that regard. But you know, the most striking thing about this year, of course, was COVID. And COVID was the situation that nobody imagined. COVID is really the panacea when it comes to everything coming to a head at once. For me, COVID presented an opportunity to not only showcase the MD side of my life, which is medical doctor, OBGYN, REI, reproductive endocrine and fertility businesswoman, but my virology work, which is equal parts my story in terms of how much it's become who I am, how it has framed my worldview. And so here I was faced with something where I had to let people know, actually, I understand this stuff and let me help. And so I'm really grateful once again for that honor and that recognition. But today I'm here to talk about the vaccine. So as you guys know, I received my vaccine on Monday, bright and early on Monday, December 21st at 6:45 a.m. I was vaccinated. I received the Pfizer vaccine. It went right here into my left deltoid. It really didn't hurt. Aside from a needle, yes, people who see the picture, they're like, oh my God, was it hurting? The truth is, I don't like needles. And my patients who are watching right now, you can appreciate that even your doctor doesn't like needles. So it is not without lots of thinking that I prescribe you the medicines that you take with injections, and why we work so hard find you needles and syringes that are comfortable but still effective in terms of depth that they have to reach, etc. But yes, I got my vaccine, and it went well. I didn't have any reactions at the time of vaccination. I'm now 48 plus hours, so I'm almost at 60 hours post-vaccine. And aside from a few, just I have to push really hard to even feel it. Then I know, oh yeah, this is why I was injected. There's a slight induration this morning, like a small wheal, over where I've been. And I felt good about that because that meant my vaccine had been working. And so, I've been doing well. I've been sleeping well. I know there have been some reports of people having chills at night. I haven't had any such thing. People reporting that they had some runny nose, sore throat. I had no such thing. All of those things, though, will be part of your body's immune system activating. And so I don't consider those to be bad side effects, to be perfectly honest with you, knowing what I know about vaccines and the immune response that it elicits. But that said, doing well, eating, drinking okay. I've been working out, no arm soreness that's keeping me from doing any work. I've been doing my push-ups. I'm a push-up newbie, and so for the past 6 days, I've been doing two sets of 5 push-ups at a time, and that hasn't in any way been impacted by my shot, so it's great. Now, those of you who are following know that on Sunday I did a live talking about the vaccines, talking about the different candidates and why I thought they were safe and what the safety profiles were. I remain of that opinion, and that's based on looking at all the data, all the studies. Currently, we now have 2 vaccines that have received emergency use authorization. And notice I'm using that terminology, which is the accurate terminology for what's happened so far with the vaccines that have been reviewed in the United States and the United Kingdom, etc. They've had emergency use authorization. Here in the US, the Food and Drug Administration authorized the Pfizer-BioNTech as well as the Moderna vaccines, both of which are mRNA vaccines. Now, a lot of people have been messaging me. I've certainly seen social media posts where people are asking, well, there are 2 mRNA vaccines. Is one better than the other? And I know as human beings, we just like being able to say we got the better one, the best one, the this one, the that one. In terms of the end point goal of both vaccines, they're going to serve the same purpose and they're going to elicit the same goal, which is protection from severe COVID disease. And I'll talk about that exact terminology because there are people out there who are also harping on, well, protection from, but not preventing infection, which they're actually one and the same because vaccines for viruses have never really worked to prevent infection. And that's because of how viruses work. And so in order for your immune system, what we call your active immune system, your adaptive immune system, to target a viral infection, you technically have to be infected. But what vaccines do is they prevent you from getting very sick. They also prevent the virus from spreading all over your body and causing an exaggerated response and exaggerated disease process, which is what we're seeing right now when people have COVID disease. And so the whole purpose of the vaccine is to prevent you from going on from just having a SARS-CoV-2 infection to becoming someone with COVID-19 disease. And I think it's really important for people to understand that, like I've always said, and most people who understand how the flu vaccine works, whenever we hear people say, well, I'm not taking the flu shot anymore because I took the flu shot and I still got sick. And we ask, well, did you end up in the hospital? And they say, no, I didn't go to the hospital, but I got the flu. And we say, oh, then your vaccine worked. And that's because the purpose of these vaccines is to help your body fight off the infection so that you're not landing in the hospital sick or requiring ventilation to help you breathe or dying. And so it's really important that we help people reframe their understanding of vaccines, right? Particularly when it comes to viral infections. And I'm going to name a list of viruses right now: measles, mumps, rubella, varicella, which is also known as chickenpox or the shingles causing virus, polio. All of these vaccines are intended to prime your body, influenza as well, which is flu, so that when you do get infected, you can quickly fight it off. Now, for many of us, our immune systems are prepared in a really, really good way that we don't even realize we got infected, because your immune system got on top of it and took care of that infection before you noticed that you were really sick, or before you took note of the mild symptoms you were having. But it doesn't mean you didn't have an infection. Technically, certain viruses stay in your body for the rest of your life, but they never get to go out of control because your immune system is keeping them in check, right? So in some cases, such as with certain herpes virus infections, chickenpox, etc., it remains in your body. It actually lives within the nucleus of your nerve cells, and sometimes it'll flare up, and that's when you get like a cold sore, etc. Your immune system's job is to recognize when they're flaring up, when they're suddenly activating, and take care of them. So that many times when you have an outbreak, it's when your immune system is a little bit depressed, a little bit suppressed. But the viruses were always there. Well, it's not the same with coronavirus, of course. With coronavirus, the goal is to keep you from actually getting very sick, which means it's keep your cells, the few that get infected, from spreading the virus all over your body and overcoming your overall health system, that you're landing in the hospital sick, or that you're making so much virus that you're spreading tons of it for a long time and making other people sick. So that's the purpose of vaccines. But let's go back to the two that were authorized in the United States. So Moderna and Pfizer. They're both mRNA vaccines. The differences between them are the following. One of them requires cold storage. And so in order to move it around the country, it has to be moved around in special cold storage units. It has to remain in that cold storage until it's time to prepare for administration. That's the Pfizer vaccine. So the Pfizer vaccine, once it's taken out of cold storage, it's then reconstituted, meaning it's diluted, and it has to be dispensed within 6 hours of dilution. So for example, when I got my shot on Monday, I received mine 45 minutes after the team that was giving the shot had picked it up from the pharmacy and brought it to where they were giving us the shots. So that's how that vaccine works, and that's how it's stored. In terms of the Moderna vaccine, it does not require that extreme cold storage. And so that in theory can be brought to more rural areas or areas where they don't have that sophisticated cold storage technology. Now in the United States, in most places, we do have those technology. And as you heard, 6 hours. So even if it had to be shipped to rural locations, if you have places that are within 6 hours of where it can be taken out of cold storage, they'll still be able to get the Pfizer vaccine. But in places where they don't have the storage to transport the vaccine and get it to people before 6 hours of dilution, then the Pfizer vaccine would not be a good candidate. So Moderna will be a candidate. The dose size, meaning the volume of vaccine received, also is different for Pfizer as well as the one versus the one for Moderna. So Pfizer is about 30 milligrams. The one for Moderna is 100 milligrams. So if you're seeing someone getting a Pfizer vaccine versus someone getting a Moderna shot, you're going to see what looks like different volumes. Now, volumes can also look different depending on the size of the syringe being used. And I'm emphasizing that because there is a video circulating that's claiming there's no vaccine in the syringe. Look at that. Well, it's a function of which vaccine is being given, the size of the syringe that the vaccine is in, and that then changes how you perceive how much is in there and where the plunger has to push. So that's the one thing. Again, stop trying to use things from the movies and stuff to inform what you think should happen, and think about all those different aspects as well. So those are two differences, right? Volume and dose, which is one is 100 milligrams, which is Moderna. One is 30 milligrams, that's Pfizer per dose. One needs extreme cold storage. One just needs sort of regular refrigeration storage. The difference also has to do with how they're dosed. So Pfizer, they're 2 shots, 2 doses, and they're administered 3 weeks apart, 21 days apart. Whereas the Moderna dose, you get your first dose, and then you have to wait 28 days or 4 weeks before you can get your second dose. In terms of protection, the evidence from the research so far coming out of the trials shows that most people have mounted antibodies within 7 to 14 days of receiving their first shot. Their T cell response is definitely primed within 7 to 10 days. By the end of your second shot, your immunoglobulins would have peaked by 4 weeks following your second shot with either one. And so really we're telling people 2 months, right? By the end of your 2 months, you should have gotten your immune system primed in the way the vaccine is intended to prime it and really get it boosted and ready. Now, so that's the way that works in terms of the vaccines. The other big difference is they're both in nanoparticles, which is little dots of fat mixed in with another chemical called PEG, of polyethylene glycol, and then the mRNA sort of in there. And the purpose of the mRNA being in there is to get into your cell and make copies of a special protein known as the spike protein. And so that's how they work. They're designed in very similar ways. The mRNA itself is not much different from each other, and the sequence for the spike protein wouldn't be very different. But what's different for sure is the technology that carries the mRNA into the cell. And because that technology is slightly different, one of them requires a lot of low temperatures, so very cold storage, while the other one gets into the cell and can be stored without needing that low of a temperature. Catherine says, when would you have a reaction? 1 day or after 48 hours? Well, when we talk about allergic reactions, we talk about immediate type reactions and what we call delayed hypersensitivity type reactions. So in an immediate type reaction, some people may notice immediately that they're having some trouble breathing, they may have some swelling, etc. That's more like what we call the anaphylactic type reaction. So far, there have only been 3 of those reported. Actually, to date, 6 total, if you include the couple that were reported in the UK as well. 6 anaphylactic type reactions that all resolved with treatment with epinephrine. Over 1 million people vaccinated to date. 6 out of 1 million. That's really, really, really tiny. Absolutely no one has died from the vaccine. No one to date has had anything untoward happen. It's very similar to what happened during the trials. Keep in mind, for example, the Pfizer trial was actually tested across 6 different countries in different ethnic groups. For example, here in the United States, the Pfizer trial participants came from ethnic backgrounds that went from white, non-Hispanic, Black, Hispanic, Asian, and Native American. And so, we really can say, and the FDA said the same, which is they were tested across different population groups. It's important to know that too. But most reactions are being seen within the first day. Some people are reporting localized swelling 48 hours later. You would expect swelling. So to explain to people, your white cells, which are your lymphocytes and your plasma cells, etc., they travel via your lymphatic system, right? Your lymphatic system is where these things travel. So if something is injected or anything at all, anywhere in your body, but let's remain focused on the vaccine. If you got an injection in your deltoid, in order to get your immune cells there, your lymphatic system has to bring them. And with that comes lymphatic fluid. So you're going to have swelling. Swelling is normal, right? Swelling is very normal. as a result of an immune reaction. And it's important for us to keep that in mind, because a lot of what we're hearing people describe, oh, the soreness, the blah, the this, that's all part of it. Yummy says, thank you for all the encouragement to the public. Oh, thank you. Thank you. Catherine says, will they cover all the mutations of the virus? So the mRNA vaccine currently is coding for the spike protein, which is a highly conserved part of the virus's genome. And that's because the spike protein is so important for the virus entering a cell that it wouldn't keep changing a lot of it, given that it's so important. But that said, I really think it's important to know that viruses mutate. That's just the nature of viruses. For any of you who are familiar with things called polymerases, or the things that make viral DNA or RNA, when it comes to viruses, their polymerases have very little, if any, proofreading capability. And so the whole purpose of a virus when it gets into a cell is to make more of itself. And so it's focused on making as many viruses as possible before the cell dies, as opposed to trying to make the best single virus, etc. And so as a result of that, you're going to see mutations. Viruses mutate, that's the truth. It's always been the case, it's nothing new. When it comes to SARS-CoV-2, there are multiple strains of SARS-CoV-2. That's always been the case. For example, we've known since March that the virus that caused the initial outbreak in Santa Cruz, California, and San Jose, that part of California, in February, March, was a different strain from the virus that was causing what we were seeing in Italy and other parts of Europe, and what ultimately came to New York. So my point with that is to say we have multiple strains of SARS-CoV-2. There isn't one. I think somehow, unfortunately, one for headlines, two for clickbait, the stories being portrayed by the media do make it sound like a lot of the virus was only one thing, and all of a sudden there's a new mutant and let's scare everyone. And the truth is, viruses mutate always. Hearing the word mutant is really a play on words. Every virus is technically a mutant from the original one. Every single new one that you spread is going to have a mild mutation. Some mutations might make a virus a little bit more able to get into cells better, so more pathogenic, better able to spread itself. It all depends on where the mutation happens in the virus. But oftentimes that mutation doesn't change the spike protein too much, but over time it may evolve, right? So viruses evolve over time. And that's why I have told people from day one, we're probably going to need boosters from time to time as they discover new mutations that are much different. We're also going to notice our own immune system needs a booster. When it comes to viruses, our immune systems need boosters over time. So that's why there are MMR vaccine boosters. You know, we tell people you should get an MMR vaccine booster once every 10 years or so. Certainly, if you're planning to be pregnant, we encourage people to get their MMR vaccine booster before pregnancy. The flu, we do it every year because the flu is really special. So influenza has multiple RNA strands in it, 6 to 8. And so they can recombine, and really change up the look of the influenza every year. And so every year we have to anticipate, using computer modeling, what the different recombinations would look like based on what's happening in other parts of the world that are already having their outbreak. And that's how we are able to generate new flu vaccine every year. Now, SARS-CoV-2, we might need updates from time to time. And so I've explained to people from day one that we're going to have first generation and then second generation vaccines, etc. It doesn't mean that the vaccine designs were wrong in the beginning. It's so we can keep up with the evolution. You know, it's the same way we're looking at computers, etc. They're always creating a new patch, a new update. I mean, just think about your iPhone, right? How many operating systems has your iPhone had to date? How many Windows versions have you seen on your computer from the time we started out with Windows back in the 90s to date? So as things evolve, as things change, just like technology changes, viruses can change as well. And so we will need updated vaccines. That's a given. That is in no way a sign that, oh my God, I've got to wait till version 3. No, because version 3, if it happens, it's going to be because there's a newer mutated virus that needs to be worked on. But it's not because right now we don't need a vaccine. Absolutely not. It's not because right now you don't need to be protected from what's happening right now. But right now, the mRNA spike protein that's being coded is still conserved even in the new mutant. So we need to know that. And people need to understand that if we have no vaccine, we're talking about numbers of transmission rates that are ridiculously high. And that's why we're not able to get control of it yet. We've learned from countries that tried the herd immunity model that said, well, let's just let people get infected, spread it as much as they want. And then no, none of our healthcare systems are able to tolerate just letting the wild virus spread and see how people end up. We also learned that people who had one infection from one strain and then got infected later on don't have immunity to just the one strain. So we need to keep all these things in mind and do what we can do. And lastly, I want you guys to think of something. So there was that recent story of what happened on United Airlines where, the person had been tested, knew they were having symptoms, knew they were positive, but still chose to fly from Orlando to Los Angeles. And unfortunately, this person then succumbed to COVID-related illness and died. But of course, in the course of having their disease progress while in flight, they had a cardiac issue that required first responders to help them. And now, although that person died from COVID, an entire flight of people had been exposed. The first responder for sure, currently there are reports that say the first responder is probably positive. The flight attendants are in quarantine. That's why you're getting your vaccine as well, if you choose to get it. You're getting it to protect people like me who, if I'm on a plane in the future and somebody announced, is there a doctor on board? And I had to run up to help someone who was in distress. I don't have to be that scared that they may have COVID and may kill me or cause me to take it, to spread it to the rest of my family, my office, my friends. So I'm asking you to think of not just yourself when you think of the vaccine. You may be young, you may be healthy, but even if you're young and healthy, you could spread it. But you could bring it home to your family, your friends, your besties, the people around you who are more immunocompromised. But also, you're helping to protect people like me if I have to run in to help you. If you had MRSA, does it give you an immunity to COVID? Catherine, I am not familiar with a MRSA and COVID connection. So MRSA, what she's asking about is methicillin-resistant Staphylococcus aureus, which is a certain type of bacteria that is now resistant to methicillin, which is one of the antibiotics that were historically used to treat that particular type of bacteria. So one, MRSA is a bacterium. It's not a virus, right? COVID is caused by a virus called SARS-CoV-2. I'm not aware of a connection, Catherine. If you're asking this in reference to a paper or something that you saw, please share it with me so I can review it. You can send it to me via message there on LinkedIn, but no, off the top of my head, I can't imagine why MRSA and COVID will have cross-reactivity or immunity. Hi, Dr. Shawana. Hello. Elsie Park says hi. Hi, Elsie. Elsie Pinks. Hi, Elsie. How are you? Dr. Smith, how are you? I saw that you got your vaccine. Was it yesterday? Winston Toussaint says, blessings, my dear lady. Continued progress continuously. Thank you. Shawana says, I hear nothing but facts. Thanks for keeping it honest. I love the comparison to cell phone updates. Thank you. Well, I think we need to make sure that people understand what we're talking about. And to me, what I'm hearing so far from the myths out there is the first myth, which is people seem to think that vaccine equals prevention. And when we say prevention, we're talking about prevention of getting bad disease. The viruses that we're looking to vaccinate you against are viruses that could either kill you, kill those around you, or leave you very debilitated. And so the whole purpose of the vaccines are to allow your body to know when these things are in your system to help you clear them before they spread more, before you can spread a lot of it. Because if the virus and you're making tons of it, you can release a lot of it. If your body takes care of it very quickly, the first thing is that you're only going to shed it for a short time. But the second is, if you shed at all, it won't be as much as you would have shed if you didn't have immunity already developed. So that's important. Dr. Nathan says, can you discuss what are the ingredients in the vaccine? It was just brought to my attention that some people believe the vaccine contains fetuses. No. To combat misinformation that is constantly being spread via social media, can you discuss what is in vaccines? Yes. Now, when it comes to the mRNA vaccines, like I was saying earlier, I think you missed this part, Dr. Nathan Anthony, but it's mRNA, which is genetic material created in a laboratory. So there are no fetal tissues involved here. There are a lot of people talking about fetal cells, etc. The two mRNA vaccine candidates, that's not the case. Now, to be clear, there are people who were so concerned about this that they were waiting to hear from their religious authority on the thought about vaccines. And actually, Pope Francis on Monday released a statement from the Vatican endorsing vaccines and endorsing vaccination. Mind you, this is a man who actually has a master's degree in chemistry. And so he understands science. He understands when you have to weigh risk versus benefit, when you have to look at the greater good, but also because he was able to review and recognize when fetal tissue was used and not used. And so, for those who are looking at it from a religious, moral, ethical standing as it relates to fetal cells, there were no fetal cells used for these vaccine creations that's being put in your body. Now, there are some cell lines that were created from way back 50 years ago that were taken from some cells that came from embryos, known as human embryonic kidney cells or HEK cells, but those were not used in these viruses, vaccines that we're talking about when it comes to Pfizer's and Moderna's. So it's important to know. And so the Pope has said, if you're Catholic or if you're leaning in that direction of needing, someone from up above or connection to the above to talk about it, the Pope actually has given a statement about it. And he said yes to the vaccination. So very important that everyone know this. In terms of the other ingredients, we talked about lipids, which are like special fat components, as well as polyethylene glycol, PEG. And I did mention that earlier in the live. So check it out. It's good information. But yes, these vaccines are safe. They weren't created in little babies. They weren't created by harvesting tissue from abortions or something like that. Don't believe that hype. It's not true. The last thing I wanted to cover is the phenomenon of something known as the people's vaccine. And I wanted to bring this up because the people's vaccine is a movement. It's a movement started by a number of non-governmental agencies, a number of international agencies, in addition to those based in the United States. And it's meant to lobby those in charge to ensure that when these vaccines are rolled out, and we've started rolling them out, their availability, that all populations have access to them, that cost is not a barrier to being vaccinated if you want to be vaccinated, and to ensure in particular that countries that are what we call low income and middle income countries also have access to the vaccine. And I really, really want to entreat everyone to look into the people's vaccine, read up on the movement. There is precedent for it as well. On Monday, I did participate in a live town hall talking about the people's vaccine. You can find it on Partners in Health on their Facebook page. It's Partners in Health / actually it's facebook.com/Partners in Health. Look that up. But really, 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 it's important that we talk about vaccines, that we talk about making sure they are accessible and affordable at the point of delivery, okay? It's really important. One of the things that a lot of us don't recognize is that a lot of the things that we now believe are just fairy tales, like measles, mumps, rubella, and you only hear about it every so often in an outbreak in communities that didn't get vaccinated in the US, but you don't hear about it so much in the US anymore. A lot of these are still issues around the world. And they're issues because most of these places were never able to truly afford getting a nationwide vaccination program going. And so it's important that we are aware of how hard it is for a lot of communities that would want access to vaccines so that they could get back to their lives, so that they could get back to providing for their families, etc., get access. So join the People's Vaccine Movement, or consider it. Go look at it. If you don't like it, move on with your life. Absolutely move on, right? But the People's Vaccine Movement is intended to make sure that the distribution of vaccines is equitable, that all people have access to it, that cost is not a barrier. I want to remind everyone in the United States, we love to travel. We love to go explore new countries. I think it's important that you know it's not okay, even though we do it, it's not okay that you get vaccinated in your country and go to another country that doesn't have access to your vaccine just so you can protect yourself from them, right? If we're really being fair and equitable, they should also have access to the vaccines so that they can be protected from you. Because now that you've heard me say today that getting a vaccine doesn't necessarily mean you won't get infected. It means you can go spread things to other people even though you don't get very sick. And so it's really important that we keep that in mind when we look at what's happening around the world and how these vaccines are being rolled out and who's having access, okay? Because right now, what we're looking at is a huge disparity between access and availability. And so let's talk about it. Dr. Shawada says, can you please discuss with the public about if vaccinated people should still wear masks and vigorously hand wash, and talk about if we can still be vectors and transmit by touching surfaces? So the short answer is yes, you can still do all of that. Now, we were talking about how vaccines work and the fact that if you got a vaccine, it does help your body fight off the infection earlier, more effectively, and thus you're less likely to spread as much virus based on how we understand viruses and immunology to work. But you can still transmit. And so because of that, you should always still be wearing your mask, because we know that the vaccines are not 100% protective, meaning, for example, with the Pfizer and Moderna, they show that between 90 to 95% of people who got vaccinated did not develop serious illness. It means, for example, for every 100 people who get the vaccine, maybe 90 of them will be protected, 10 may not. So until your body is done doing what it's supposed to do, until we know for sure how you're doing, wear your mask. We do know that we need somewhere around 70% of the population to be vaccinated before we can start really believing that the load that could be spread will be decreased. So it's important then that we all advocate, not for ourselves only, but for our families. But until we can really get a larger segment of the population vaccinated, we need to be mindful that we can still catch COVID, but we can also still spread it. And that is critical to understand. So you do have to wear your mask. You do need to wear your mask correctly, meaning wearing it to cover your nose, your mouth, your chin with a nice seal. Ideally, if you can, you wear an N95 mask or a 3-ply mask. If you don't have access to those, then we know any mask is better than no mask. So wear your mask, wash your hands, use your hand sanitizer. I've got hand sanitizer everywhere. The bigger thing I have been working on is making sure I don't become addicted to always thinking I need to, use it every time, because I use hand sanitizer a lot, and I always have from the time I was working on my PhD to this day, as well as then becoming a surgeon and a physician. You know about that because that is how you prevent spreading different things, bacteria, viruses, other things. Dr. Shawana wanted me to talk about touching surfaces. So surfaces have things called fomites, right? Particularly the surfaces we're talking about are like doors, door handles, etc. You know, every time you touch a door handle, you transfer things from your hand to the door and vice versa. You pick up things from the door, right? And so if you're someone who's out there carelessly not washing your hands, coughing, touching, blah, blah, changing, you're going to be touching and moving viral particles around. And it's not just viruses, guys. So it's not just SARS-CoV-2. Hand washing is important, and wiping down surfaces is important, period. Okay? It's important even if we weren't worried about SARS-CoV-2, because you can transmit other things that way. If you use the bathroom, let's say you went to number 2 and you didn't clean your hands, you can have microscopic bacteria from your own stool that you'll then transmit to other people and make them sick. You know, there's a reason why when you go to the restaurant and you see the sign that says everybody should wash their hands, it doesn't only apply to the people working there. It should be for you too, right? And so if you go anywhere, you should be cleaning your hands, washing your hands, cleaning surfaces. If you're going to the supermarket, wipe down the surfaces on the shopping carts, etc. There's this benefit to that. That benefit's been shown from the time of 1918, even when we go back there to when things like the flu spread in 1918. So very important, very important. Thank you so much for that question, Dr. Shawana. Joanne Cummings said, good night, Dr. Duke. Yes, go ahead and share. Thank you so much, Dr. Shawana. Share, share, share. Well, I'm going to try and keep coming in and just reiterating a lot of this over the next few days. You know, the holiday is coming. Tomorrow's Christmas Eve. For those who are viewing on the clinic page, Nevada Fertility Institute is closed tomorrow through Sunday night. We will still be answering texts and emergency calls, but please keep in mind that the clinic is closed. And so we will be handling emergencies as usual and time-sensitive needs as usual. But if it's an issue of just scheduling something or requesting a prescription that you need 2 weeks from now, we will get to it on Monday. That is our promise. Okay, so to everyone, happy holidays. You know, really think about getting the vaccine. Think about your friends, your neighbors, your family. Think about people like me who are out here and working really hard on the front lines and willing to put everything on the line to help you stay alive, help you achieve your dreams of growing your families, achieve your dream of, you know, surviving cancer, achieve your dreams of everything that you are hoping for. All we're asking is you help us. I recognize that you need information. I recognize that there's a lot of mistrust in science and medicine. I recognize that a lot of misinformation was peddled out there this year that has further undermined people's confidence in our system and our news. But I also am here to tell you that if you look back, I didn't mislead you. I always kept it real. And I always went and did the research and came back. And I did the same here. And so here's to wishing everyone Merry Christmas, Happy Holidays, Happy Kwanzaa for those who are celebrating. And I'll see you in the days coming. Bye.